I guess we're running late, so let's go. All right, software project management. That's what we'll be talking about today. Okay, so let me begin. So Adam gave a pretty thorough introduction. I'm a software engineer, but I've had many roles. I've started companies, I've owned companies, I've worked for companies, I've managed projects, I've been engineer in projects, I've been a lead engineer, I've sort of had many positions in different companies. And so my goal today is really to share with you some of what I've learned along the way. So let's jump right in. So the reason why I got into this business, the reason why I got into software, was basically because I didn't want to be bored. Originally, I wanted to be a biologist. Well, I wanted to be a doctor, and I love biology, so I liked cutting things and looking at anatomy and physiology and stuff like that. And I loved that. But the problem is I couldn't imagine doing one thing for the rest of my life. And so I liked this idea of working in different domains. And actually, the reason why I got into software was exactly for this reason. Because software allows you access to all the different industries simply because programming, computers, software exist everywhere, literally everywhere. It doesn't matter whether you're doing government stuff, military stuff, I don't know, biology, genetics, anything you're doing, you are working with software. And so this is why I got into this business. Now, there's a flip side to this, which is when you're working with different industries, you need what's known as domain knowledge. You need knowledge about these industries. Why? Every time you're building software, you're building it for someone, right? Software is a tool, right? It's to do something. So when you're trying to build a solution for someone within a certain industry, you need to be able to communicate with them to understand what it is that they need. It's just, right? It makes sense. So that means you have to be able to understand their problem. This is actually not that easy. Imagine talking to someone who's doing research in genetics, and you're trying to understand how you can help them. If you don't know about genetics, if you don't know about biology, you're going to have a lot of trouble communicating with them and trying to understand what solutions they need, right? Same for law, same for any other domain, right? So one thing, every time you begin talking to a customer, and it doesn't matter whether you're an outsourcing company or you're building a product, you're going to be building software for someone. You're going to have a customer. When you're talking to your customer, it's important to understand what it is that they need. What problem are you trying to solve? Often customers will tell you what they want. Like someone will come to your software company and say, hey, can you build me this? The first thing you should ask them is why. And they'll say, because I'm telling you, because I'm giving you money, right? No. Why do you want that software? What problem is this software trying to solve? Dig deeper. Don't just build something. Understand the reasoning behind what you're building. This is the only way when the final product is actually going to match the need. Customers will often tell you stuff that they want without actually realizing that what they want does not match what they actually need underneath, right? And it's your job as project managers to really understand this correctly so that your team implements something that is useful in the end. Fair? Cool. Okay. So once you understand why you're building something, right, it's important to understand the roadmap. It's important to communicate this to your team. Don't just say, we're going to build this. Explain why you're going to build this. In other words, attempt to echo the information you got from the customer to your engineers. Remember, engineers are pretty smart. And what they will often tell you is, wait, well, why didn't you do it this way? What about this? In other words, they might offer other ways of solving that problem. My point to you is this. Don't begin by thinking about what you're going to build. Begin by thinking about why you're going to build it. Once you understand the need that you're trying to solve, the problem that you're trying to solve, then you can begin to brainstorm about the optimal solution. If you begin with the solution, we're going to build this, there's no room for discussion. There's no room for optimization. You end up building that. And this may not be the optimal thing for that. Got it? It's a simple thing, but you can't imagine how often people end up building software that is useless. It happens all the time. Oh, Chen, on a second. So, Why is programming so difficult? Why is software engineering in general so different from everything else? Well, it's not like manufacturing. When you're building a car, right? Okay, you understand there's an assembly line, you know, this part puts this screw in, this part does this in, and you have a process. And this process is measurable, and you can get statistics and analytics about it. And later, if you want to build a slightly different car, you have all this information, prior knowledge about what it took to make a car, and you can make various predictions about how long it will take to build this other car, right? And you can be pretty accurate about your predictions, about your estimates. Engineering, programming, is a process of discovery. It's a process of trial and error. It's not manufacturing. It's not we do this, this, and this, and we're done. Every time an engineer sits down in front of a computer to code, they have no idea what's waiting for them. It's a discovery process. They are usually, every time they sit in front of a computer, coding something or building something for the first time in that way. For the first time. Unlike where manufacturing, where you've done something similar and you're doing some tweaks, when you're writing code, you are creating code from scratch, the new way, somehow. And as you're building code, you end up finding problems or issues. Oops, I can't do this. Oops, you know, this ends up being a lot more difficult than I thought. Wait, how can I, oh, the path that I took is incorrect. Let me delete all this code, rewrite it this way. It's a process of discovery. It's a process of trial and error and again, and repeat and repeat. This is why making estimations in programming is so difficult. Because an engineer at the beginning can't tell all the steps that they're going to take to the end. Furthermore, you don't know the number of steps, so you don't know the percentage of completion. Make sense? So, this is one of the things that makes it so difficult to estimate in engineering. In fact, there's a joke about this. Do you guys see this picture? There's a guy trying to put all of this into a car, and it says, this guy's a software engineer, you can tell by his awesome estimation skills. Oh, come on, wake up. Okay. So, this is a problem, right? So estimation in our industry is a big problem. So what do we do? Well, it turns out that estimating long term is practically impossible, right? And if you ask an engineer, will you build this in 1 year? And engineers are optimists. You know, they'll say, yeah, I can do it. And then they start coding and realizing all the problems that happen along the way and go, oh, oof. And then they come to your office, oh, you know, sorry, it's not going to happen. If they give you an estimate and say, I can get this done in a year, it might take 3. Literally, this could happen. So long-term estimates, generally speaking, are incredibly inaccurate in our industry. And so what has happened? Well, what people have done is, wait, instead of making long-term estimates, why don't we make short-term estimates? And instead of, well, what's a short-term estimate? I don't know, 2 weeks? 3 weeks? Okay, so let's make an estimate, figure out what we want to build it in roughly that amount of, roughly, by the way, because even the 3-week estimate might be, okay, build it in that time, and then do another estimate and build, and these are called sprints. You guys heard of Agile, this whole notion? Yeah, hands up if you know Agile. Ooh, some of you. Okay, cool. So, okay, the idea is basically to break up your development process, not into like, you know, we build it and then we're done. No. It's we build it, design it, test it, whatever, go through this whole process in one sort of sprint in a 2-week or 3-week section. And then you do another section, and you sort of keep doing this until hopefully you see the carrot in the end. This is the process of Agile, okay? And so this was the solution. Don't try to estimate long term. Estimate in short bursts, do that, go to the next one, do that, go to the next one. Any questions up until this point? Am I speaking too fast? You're okay? Cool. Okay, now, one of the things that engineers and managers often optimize for is speed. Let's build it fast, they say. And it makes sense because a customer comes to you with a problem and they're saying, we're losing money. We know if we had the software, we would, I don't know, save millions of dollars every year. We want this software yesterday. Go, go, go. And you go, 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 go. Engineers are like, go, go, go. Ah, right? And everyone's like typing and stuff is happening. The problem is, it's easy to build something fast. Something is the operative word. Not something good. Something. Software engineering, programming, and Douglas Crockford says this, and I agree with him 100%, is the most difficult thing, the most complicated thing that people do. The most complicated thing. And let me explain why. We have a contract with the computer that says our programs have to be perfect for every possible inputs, for every possible state. And if the program is not perfect, the computer has license to do the worst possible thing at the worst possible time. That's a bit of a problem. And we are not perfect. We are bad with, humans are bad with perfect. And here's the crazy thing. Even if we achieve perfection, we would not know it. There are no tools, there are no measurements that we can use that will tell us your software is perfect. Testing does not do this. Testing tells us about bugs. It does not tell us about non-existence of bugs. With me? So this is kind of a problem. So having good tests, and we'll talk about this soon, is important, but having good, solid software methodologies is also important. So the point I'm telling you is this. Don't optimize for how fast you're building something. Optimize for building something correctly. This is key. If engineers come up to you and say, we have to build something fast, I don't have time to write tests, they are optimizing for speed of development. They are not optimizing for speed of correctness. You want your software to work correctly, not to just exist. Fair? We'll get to that in a moment. Now, a few details, a few ways that managers often try to make software happen faster is the software project begins and it's going, and already people are like writing a lot of code, and much later into the development process they say, we want it to go faster, and so they just hire more people, right? Because more engineers means more coding, and more coding means faster. Yes? God, no. No. Okay, remember, software engineering is discovery. Software engineering is applying knowledge to a product. It's not like manual labor where if you add another one, now you have two people hammering. It doesn't work that way. It's an intellectual endeavor. There's a lot of knowledge that has to be put in, not only your own knowledge, but also your knowledge about the program that you're modifying. When you start from the beginning, the whole team knows nothing about the project because there is no project, right? As you begin to develop the project, as the project builds, it becomes more and more complex. But the team is building it. And so the team is constantly reading it, working with it. So at some point, the team understands the project. They understand the details, the methodologies, the reasoning behind why the structure of the code became the way it became, right? When you just throw someone in there and they go, hi guys, what are you doing? And they go, well, we're writing this code. Oh, cool, a variable. Can I change that? God, no. Why? Because Chaka, right? That person doesn't know what's happening, right? The other team does. Furthermore, it distracts the rest of the team because now the team that is now working has to stop working and explain to this person all the various pieces that they've done. And so it slows the project down. Sometimes it's necessary. For example, one of your engineers quits. You need a replacement. Sure, sometimes it's necessary. But understand there will be a penalty. Understand that there will be a dip in your process, and then eventually, once that developer gets up to speed, then development will go up again. But understand that there will be a decline in the beginning. It's a penalty you have to pay. Okay? Okay. Automated testing is absolutely necessary. Now here's the problem with automated testing. It doesn't show the customer anything, right? When the customer looks at the software, they don't see testing, right? They don't see tests. They don't go, wow, what a beautiful test. I love that. That's going to save me millions every year. No customer thinks this, right? And managers, when they see a demo, a nice shiny demo of some cool app, they go, wow, that's pretty. Okay, no one sees tests. No one is wowed and excited. Tests are not sexy. Tests are not beautiful. Tests just sort of do something, right? But they're critical because without tests, how do you know? Think of it this way. Every time an engineer sits down to write code, they're not just writing code, right? They're writing code to do something. They're trying to match a spec, a specification, that says your code should do this. How it should do it is up to the engineer, sure. But the manager says, you know, your code should really do this. Okay, how do you know, or how does the engineer know that they've fulfilled this promise that they've made to you, that their code is going to do this? A, B, and C. How do you know? How can you validate that fact? Furthermore, remember that software is dynamic. It's not like they write it once and done. No. Software is constantly changing. There are new features introduced to the software. Software is modified for refactoring, for cleanup. It moves all the time. How do you know that when software moves around, you're not going to break something? It happens all the time. I've seen it. Where a bug is reported by a customer, engineers go in to fix the bug. They fix the bug successfully, but they break 3 other things. And then the customer files 3 other bugs, they fix those and create another 9. And the project just sort of snowballs from there. Right? You've seen this, right? The only way to prevent this is to have automated testing to make sure that when you check a change in, when an engineer modifies something, there's something to tell it, hey, by the way, you just broke something over here. Oh, okay, oops. You know, they don't just blindly change something, check it in, deploy it, and then have the customer see it and file a bug. You absolutely need automated testing. And again, it's one of these things where I hear it all the time. Look, we don't have time. We have to develop quickly. We have a deadline. We're writing code. We don't have time for tests. Again, optimizing for the wrong thing. Optimizing for speed of development. Yes, your development, yeah, you'll get there. You will build something in that amount of time. But if you don't have tests, you lose correctness. And if you lose correctness, you're building shit. Sorry. Right? And no one wants to use your product. With me? Okay, cool.
I have a question.
Sure.
Is it also true about having the tests for not very big projects? For example, you say your project not big enough, so we can go without tests.
Okay, so good question. So the question is, does the size of the project matter? Does correctness matter? Is really the only question you have to ask. Any software can be flawed, right? Can have bugs. If it's okay that your software has bugs, then it's okay not to have tests. If you want to minimize the number of bugs, you have to have tests. It's really... Now, having said that, remember, I'm talking about products. If you're building a demo, yeah, it's okay if demo has some bugs. When you demo, just like, oh my God, you've done this, I'm sure. Don't click on this button. Engineers will tell you, like, it will like alert, oh my God, you know, something like this. Okay, if you're doing a demo, yeah, it doesn't matter. You just want to throw something together quickly just to click around and go, you know, okay. But if you're building a product that's going to actually, you know, do something important, correctness is kind of important. And if correctness matters to you, then tests are necessary. Correctness and testing goes hand in hand. If you don't have one, you don't have the other. Okay, John. Cool. Other questions? Keep going. Okay, so as code is modified over time, right, it becomes dirtier and dirtier, literally dirtier, okay? Every time a feature is added to your product, something is changed. And let me give you guys an example. Imagine you move into a beautiful apartment, and it's awesome, and you like design it exactly the way you want. You know, you have like the nice TV, and like, you know, you organize the chairs, and the bathroom is just, wow, calm, right? Everything is just, it's a beautiful apartment. Then someone gives you a gift. They give you like a blender. And you go, oh, I need to put a blender into my room. So you like put it in your bathroom. And then you go, oh, wait, I need like, the number of sockets aren't enough in the bathroom. So you like drill a hole through the wall to get a wire from another room into that room, so that you can connect the blender that's in your bathroom. And then you go, oh wait, I have bananas. where was the refrigerator? I don't remember where the refrigerator is. I'll just buy another one. You buy a small refrigerator and you put it on top of your television. And you stick it in there, right? And then you go, wait, I need a wire to connect this to, so, oh, I know, there was a plug in the kitchen. So you drill a hole and you put the wire into the kitchen. You're laughing. This is literally how software works. When engineers are told, add this feature fast. Okay, actually, let's do this. I tell you, put this blender into your apartment as fast as possible. Go, go, go. Are you going to go all the way to your kitchen? No, you're going to go in and be like, man, look, you're going to open the door and just put it there. And just going to connect and run out. Because we're optimizing for speed, right? Go, go, quickly. Put the blender in, get out. Then I say quickly, go in, put bananas in your fridge. Go, go. You're not going to run all the way to the fridge. You're going to quickly throw it into like a tiny thing and get out, right? Again, optimizing for speed creates garbage. So what would you do? Well, there are a few things. One thing that is very often done is people optimize for speed and end up in an apartment like the one I described. Imagine that apartment like 2 months later with more holes and more wires, right? Imagine that. At some point, if you walk into the apartment, you will die because there's like electricity running everywhere, right? Like you can't even work with that, but you can't live in that apartment anymore. So what do? You go to your manager. We have to do a big refactor, or we have to rebuild, or you have to just rebuild the whole thing, right? You have to literally rewrite your system again. How often? I don't know if you guys have experience in the industry, but hands up if you've had engineers come up to you and say, we have to refactor everything. Okay. Anyone who's working in the industry, I'm sure, has had this experience. I've had it all so many times. Or one step beyond that is we just have to this is crap. Like we can't. We have to just rebuild it. And and that's okay. Like, yeah, if you have an apartment like that, it's better you just build another one. Like, I would never go in and try to bring all of that electricity back and figure out where else it goes. I would just rebuild it and build it nicely, right? That's okay. But the point is, if that happens, that is a failure of management. Management class. Ooh, it's your problem. Okay, that's a problem. It means that you're optimizing for speed. Put the blender in, get out. Quick, quick, quick. No. The goal isn't to put the blender in quickly. The point is to put the blender in the correct place, to set it up properly, and then leave. Go to the kitchen, find the right place, move some things around perhaps. Maybe you want to put it on the counter, there's a toaster there. You have to move the toaster, right? You have to arrange your code slightly, move things around before you put something in. That's called refactoring, right? Moving things around in your code. Now, when you move things around in your code, how do you know if you've broken something? Yeah, you have tests, exactly. And if you do not have tests, what happens? You either don't move things because you're terrified, because you're worried that if you move the toaster, the house is going to explode. Or, right, you do move the toaster and the house does actually explode. In other words, you introduce bugs, right? Okay. So you understand how we're building on top of this, right? So refactoring, constantly keeping the code clean is absolutely necessary. So you need to give your engineers proper time, not to just implement the feature. Don't just add a toaster. Do it right. They should be keeping their code clean as they go. Interesting point now. You might be asking, okay, so I should just say, hey, keep your code clean, and engineers go. And they just throw a toaster in and go home. Oops. What do we do? Well, so a lot of project managers or potential project managers have asked me this question. Do I need to learn how to program? Hands up if you have that question. Oh, okay, one person. Okay, the rest of you don't care. Okay, no problem. No, I'm kidding. Look, your engineers are building something. It's the thing that they're building isn't what you see. What you see is the outcome of what they've built. It's the result of what they've built. It's not what they've built. What they've actually done, the work that they've actually done, is the code. Anything that you see, anything that's running, anything that's flashy, is the result of that. But that's not what they created. What they created is the code. If you can't read the code, you don't know what they've built. So how can you manage a team that's building something that you can't understand? Imagine trying to manage a team that's building a building without being able to see a building. Yeah, I think that's good, yeah. You can't really imagine that, can you? Or trying to not able to read the floor plan. Like an architect designs a building and you go, yeah, it's fine, but you didn't even look, no, it's fine, it's good. But don't you want to see the designs? No, it's good. Sure. Does it have a toaster? Yes, it has a toaster. It's fine. Right. It doesn't make sense. And so what's necessary is, as your engineers are writing code, to do what's known as code reviews. Code reviews is when you literally open up the code that they wrote and you read it. And ideally, you don't do it alone. You do it as a team. Why do you want to do code review with a team? First of all, so other engineers can understand the code that that person wrote. Why is that important? Because someone else might have to fix a bug in this code, right? Makes sense? What if this engineer quits? You want other engineers to know their code. Second, this is a good way to make code better. You want to make sure that code is readable. If you can't look at a piece of code and understand exactly what it does, it's a low quality code. It's crappy code. That code needs to be rewritten. So what happens is when you look at the code that, say, this person wrote, you have that person try to understand it. And if there's something that they don't understand, that person has to rewrite it. They don't comment. They don't say, oh, just add a code commenting that says what this, no. You rewrite the code itself. Because if the code can't be read properly, if it's not easily understandable, it's too complex. And complexity is the worst thing you can have in your system. You want to minimize complexity, so you want to keep your code simple and easy to read. With me? So, as you have your engineers throw a blender into an apartment, look at where they put the blender. That's it. Cool? Okay.
I have another question.
Yes,
Sorry.
go.
So, for example, say I start learning coding, but
Yeah.
I need many years, for example, to have the same level as my developer has. So, if actually I don't have that much experience, can I understand
Yes.
the quality?
Okay.
of this
Let me explain something to you. So programming, there's knowing programming and there's being a programmer. It's like knowing how to read and write and being a poet, right? You can go to school and kind of learn the alphabet and kind of figure out how to read and read a few books and then maybe write a few papers. But there's a world of difference between that and Shakespeare, right? A world of difference. Just as there's a world of difference between someone who knows coding and a programmer, a software engineer that's worked in industry, that has experience, that understands systems and so on. A world of difference, right? My daughter is now learning to program, but okay, it's not the same. So, what I recommend to you is this. Learn programming as in the basics. That will at least give you an idea of how to read code. You don't have to build systems and develop systems or write code. Just be able to read and understand what it does first. Second, remember, you're not alone. Code reading isn't just done by you. The whole team gets together and they discuss code, right? So in fact, if you manage it just right, you can actually get other engineers to do your job for you. Because other engineers will look and say, wait, that doesn't look right. Maybe you might want to move it there, and the other person says, oh yeah, okay. And they kind of figure it out themselves. But still, you want to be able to at least understand what they're saying. You don't want to just sit there and go, yeah, good. You want to have some confidence in what they're talking about, yeah? So no, you don't have to be a super programmer to deal with programmers. You just have to be able to make sense of what they're saying. Cool? Okay. Security. So you can build, again, the greatest product in the world, and just as bugs are not acceptable, security holes are also not acceptable. If you can write the greatest software in the world, if you're concatenating the results you get from a client into your queries and then querying a database, you have a potentially very dangerous product. In fact, your product, your solution, has just turned into a liability. You've given a window into a hacker to hack your customer. Think about it. Your customer might have a database full of credit cards and personal information, and by writing software that has security holes, you have granted access to hackers into your client's database, potentially. That's a huge problem. No. But again, when you worry about security, when you go through all the various things that need to go into to build secure applications, no one is wowed by this. No one looks at the site and goes, wow, your site looks so secure, right? That doesn't happen. You don't get prizes for security, just as you don't get prizes for testing. But it's absolutely necessary. Now you might say, okay, what do we need to do to have security? What does that mean? Secure applications. What does that mean? The problem is this. In order to be able to write secure applications, programmers have to know how to write secure applications. Security, unfortunately, is an opt-in model. If you don't know how to do it right, by default, you get it wrong. This is why so many people end up writing insecure applications. This is why the security business is booming. Because most engineers don't know. So how do you solve this problem? Them not knowing. Can anyone guess?
Getting good quality developers.
Good quality developers, and there's a second one. Always educate. Education is absolutely key. Again, a lot of people say, wait, but there's time constraints, right? We have a deadline. We don't have to have time to write tests. We don't have time to bring in someone to educate our engineers. We're writing code. We're building stuff. Again, you're optimizing the wrong thing. You're optimizing development. What you should be optimizing is correctness. And knowledge is the only thing that will get you better software. There's a good cartoon. Two people are talking. There's like management and engineer. Management says, we don't have time for education in this company. We have deadlines. What if we educate our engineers and they leave? And the other engineer goes, what if we don't educate them and they stay? Right. Remember, we're in the industry where our business is all about applying knowledge to product. The more knowledge engineers have, the better product you will have. Do everything you can to optimize for that, not for speed. Getting a product that is bad faster isn't as good as spending more time but getting a good product. And again, I'm telling you this, and believe me when I tell you this, most of the time in a software lifecycle is not spent on building something. It's spent on maintenance, debugging, fixing, adding features. It's all that rest of the crap that takes up most of the time. So don't optimize for this, optimize for this bigger one. If you make few errors here, you will have to have less debugging here. And the full life cycle of the software will actually become shorter. The development path will become shorter. Most people don't believe me. And if they do, in real life, they never implement it. They always say, build fast, 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 throw the blender in, go, 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 and then the blender breaks and there's an electric fire. And they go, oops, and now they have to call firemen, and there's a whole problem, and now the building is burnt, you have to repaint the walls, and guess what? It takes that much longer to finish. Literally, that's what happens in software. With me? Yes? Okay. Okay. Right, so this is the point I was making. Remember the goal. That's your start, that's your end, right? The goal is to get here. You will have milestones, which are sort of these things that you want to accomplish along the way. And these are really there just to keep your engineers kind of on schedule, keep them working. Again, short estimation, short bursts of execution, sprints, if you will, in Agile, so that you can sort of keep going and getting there. The problem that will often happen is when you set a deadline here, engineers will try to meet that deadline so that they can they can look good and they can get a bonus and they can get praises and they can get a raise potentially, right? Because how else do you do it, right? Engineer does a good job, you give them a raise. Makes sense. How do you know if an engineer did a good job? Well, most managers say, well, he met his deadlines, closed all his tickets. She, wrote unit tests and everything passes. Everything is good. Look, it's here. The thing is when you have a deadline here, people will often do everything possible to meet the deadline, which includes not putting the toaster or the blender in the right place. In other words, they will hack the code. They will not refactor the code. They will not keep the code clean. They will avoid writing tests. They will skim out on doing any extra security measures in their code. They will do whatever it takes to meet the deadline. Why? Because that's what they're optimizing for. They're optimizing for the short-term deadline. So they're cutting things, right? They're hacking. They're making quick decisions that are not optimal for the software just to meet the deadline. The problem with that is that then they do it again, then they do it again, and eventually you end up with dirty, smelly code that can't scale. So what you want to do is optimize for the long run, not the short run. In other words, while you have deadlines, they should not be firm. First of all. Second, always make time for the various things that I said. Code readings, for example, are absolutely critical. If you can't look at the code, you don't know if the engineer wrote the tests, put the toaster in the right place, refactored, etc. So code readings are necessary. Testing is necessary. Make sure that the code is read carefully for security flaws. That's also important. Make sure that the code is read carefully for cleanliness. Is the code clean? Is it easy to understand? If it's not, the deadline does not matter. You're not done. The deadline doesn't tell you when you're done. Done means done. Huh? Uh-huh. Good. Okay. This is the point. This, by the way, means patience in Japanese. Just okay. Okay. Programming takes time, whether you like it or not. This is the point I'm making. It takes a certain amount of time to program. A woman can't have a baby in 3 months. You can say, please do it. I'll give you more women. 3 women, maybe you can make it in 3 months. No, it takes 9 months to make a kid. Like it or not, that's what it is. Same thing with programming. There is time. You have to grant engineers time. And if you don't, you will pay for it in the long run, because you will get garbage at the end. Cool? Okay. What is programming? Again, it's applying knowledge. It's thinking. That's what engineers do. It looks like they're office workers. It looks like they're just sitting there, typing, maybe on Facebook, gaming, whatever. But when they're working, they're thinking. You don't want people thinking and making critical decisions in your code that might create massive problems later at 3 o'clock in the morning when they're exhausted. A lot of managers will say, I will extend the work hour. We're not leaving until 10 o'clock today. They will give people bonuses if they work all night. Oh, you worked all night? That's great. Oh, you stayed until 10 o'clock at night at the office working? That's awesome. I love that. Good job. But what they're doing is they have exhausted engineers. So they're promoting being tired. That's not a good thing. What you're promoting is people writing code, making decisions in your program while exhausted. That's not optimal. Remember, optimize for correctness, not for speed of development. Correctness. And it's difficult to do something correctly if you're exhausted. Fair? Cool. Okay. This is also very important. I've seen this in so many companies where an engineer is working, and they're like, oh, let's see, this variable is here, and I'm going to call this function, and this object is here, and I'm going to refactor, and what? Manager is there with the coffee, usually. Hi. Hey. How's it going? Fine. You going to meet your deadline? I think, yeah. Good. Keep up the good work. And the manager feels good, they're managing, they've done their job. Okay, listen. Remember, it's a creative process. And engineers will often get into this psychological state called flow. Do you guys know about this? Flow? It's something artists do this, authors can do this. Flow is when you kind of, it's a high level of, it's like intense when you focus on what you're doing, and things just start rolling. Like, you just start getting stuff done, and and you're really focused, and you know exactly what you're doing, and boom, 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 you're just flying through things, and you're building things, and you got it. You just feel like the master of the universe. The problem with flow is that any slight interruption will immediately get you out of flow. Immediately. This is the problem. The time when engineers do their best work is when they're in flow. Is when they're feeling that intense focus, when they got it, and they have the variables in their mind, and they're remembering the names of the function that they're going to call, and the objects, and they got the solution, they have the algorithm, and they're coding it, and they got it all, and suddenly they get this crap. Right. Don't do that. So talk to engineers when they're getting water, talk to them before or after, whatever, not when they're programming, ever. Do not disturb them when they're programming, okay? Okay, so that. Meetings. Okay, managers, you. Meetings are incredibly expensive. If you want to do it mathematically, just literally multiply the amount of money you're paying all the people to just sit around the table and watch you, listen to you talk, or have them talk to each other. And remove all of that time, by the way, from the actual development of your product. Have meetings first only when it's absolutely necessary. And guys, trust me, a lot of times when you think it's necessary, it's really not, number one. Number two, only have the meetings with people, only invite people that actually care about the meeting. Don't just say, let's all have a meeting. Okay, and then half the people are on their laptops, like that guy, coding or something, right? No, only invite people to the meeting that actually, their presence matters to the conversation. Don't just invite random people just because, so you can feel like you're a manager. Don't do that. Cool? Go. Okay, and again, so I know this is nothing new, but just let me explain in the context of what we're doing. Why is learning so important? As managers, again, you are dealing with customers and engineers. That means your job is to not only have domain knowledge, that is to say knowledge about the customer, so you can understand, first of all, you need to be able to speak their language. And the language of a biologist, the language of a lawyer, the language of of an economist, is very different from regular language. They have terms, right, that they use. They have whatever, right, acronyms and so on, that you have to be aware of when you're speaking with them, right? So, and why does that matter? Because remember, the goal is to communicate with them in order to understand their problem. And then later to communicate with them, to explain to them what's happening on the software side, to give them progress updates so they don't feel like they're in the dark. They understand what's happening on the other side. They understand what they're paying for, right? So you have to have domain knowledge. You constantly have to learn about the domain that your customers are in all the time. Secondly, you have to learn about engineering. Why? Because you're talking to engineers. You're doing code reviews. You're hearing things like, memory leak. What the heck is a memory leak? Oh, we can't ship the product. We have this memory leak that slows the system down. Okay, now I have to go explain to the customer, sorry, we can't deliver. Why can't we deliver? We have a memory leak. What the crap is a memory leak? Plug it. We don't know. We're debugging. What the hell is debugging? Right? Like, you can't speak the same language with the customer that you speak with an engineer. But you have to understand this, and you have to understand that. And you have to be the bridge in between. In order to do this, the only way you can do this is to constantly learn. Because engineering changes, the terms change, the processes change. The domain of the client that you're working with is also constantly in a state of flux. And so you have to constantly educate yourself. Secondly, remember, engineering is about applying knowledge to product. You want knowledgeable engineers. That means investing in their learning is absolutely critical. Secondly, by the way, engineers will thank you for it, because engineers like it when management cares about their careers. And when you invest in them, when you educate them, they feel like you're investing in them, not in a product. Even though you kind of are actually investing in the product, because the smarter they are, the better product they build. Make sense? Yes? Okay, that's me. Find me on Facebook, email me, whatever. I love you guys. You're awesome. So, questions. Go. How much time do we have? Ooh, that was fast.